Hello and welcome to the video on Adaboost Implementation, where I will be showing you how to implement Adaboost classifier in Python. I hope you have already seen the previous two videos. If not, I would highly recommend you to watch those two videos first and then continue with this video, because I will be using the same notations and same formulas here. So in this video, I will teach you how to implement the mathematical part that we have already learned in the previous video. So let's get started. We will study this implementation in three sections. Firstly, we will implement the decision stump class, which is basically the building block for the Adaboost classifier. Secondly, we will implement the Adaboost class, which is basically a collection of functions which will first initialize the number of decision stumps that we want in our Adaboost classifier. The fit function, which will try to fit on the input dataset that we want, and the predict function that will predict the desired output on the dataset that we want to which we want to predict on. So, and third and the final one is the main function, where we will call the Adaboost classifier on a particular dataset. And for this particular video, I will use the MNIST dataset. So let's get started and see all these three sections from back. Firstly, we will import these basic dependency to work with the dataset. Coming to the decision stump class, these four things are the basic components of the decision stumps: with polarity, feature index, threshold, alpha, that you all might have seen in the previous videos, and I've also mentioned in the comments, and you can see it where I can give you an overview. Polarity give you whether it is yes or no, or for our case it is -1 or 1. Feature index, which feature is being taken by that particular decision system to make decisions. Threshold correspond to the threshold that has been chosen for that particular feature to make the decision, and alpha corresponds to the correctness, or you can see the contribution of that particular decision system in the decision making process overall. Now coming to the Adaboost class, you might be familiar with all these formulas, as you might have seen this in the previous two videos, and if not, I will say that was that first, please. Now coming to the Adaboost class, coming to the first function, that is the init, which will initialize with the number of classifiers that we want in our Adaboost classifier. Secondly, we'll come to the fit function, which will take two inputs, x and y. Where x and y are the data frames, where x correspond to the input data, and y is a target variable that we want to predict. Now, these things will give us the number of samples, that the number of data points that we have, and the number of features for particular data point. And w correspond to the weight of every data point, and initially it will be equal for every data point. And as soon as we iterate for every classifier, the value of t will change for every data point. Now, in this particular for loop, for every classifier, first we will create the decision stump and initialize the minimum error to infinity, as we want to reduce the error to as close to 0 as possible. Now, as I've already said, for every decision stump, we'll choose a particular feature to make decision. So we will iterate over all possible feature and take the best one. And for particular feature, we also need the threshold. So for every feature, we will choose a threshold that we want to work on, and that particular threshold will be one from the unique values of that particular feature. Now, after making the prediction, taking out that particular unique value as a threshold, we will get the error, and if that particular error is less than minimum error, we will save that threshold and that particular feature for that particular stump. and we will do the same for every classifier, and we will attach every classifier with a particular threshold and the particular feature. Now the contribution that every classifier will make will depend upon this formula that we have already seen here, that is 1 by log of 1 minus epsilon by epsilon, and the prediction, we will make the prediction using those things, and then we will update the W accordingly, and the W will increase for the misclassified sample, as we already know and as we have already seen as well. Coming to the predict function, we will which takes x as input, which is also a data frame on which we want to make prediction upon, right? Now first we will make the prediction equal to 1, right? We will predict everything as yes. Then after that, depending upon the threshold, we will change the value of that predict value, because we only have two values, 1 or -1. Now after making the prediction, depending on the decision stump having a particular threshold, we will the prediction for that particular classifier will depend on alpha, as we have already seen where alpha stands and how much contribution that particular decision stump is going to have. And at the end, we will flatten that particular result and return that particular prediction. After initializing all the functions and everything, we will come to the main function. We will first load the dataset. That dataset that load underscore digits correspond to the preloaded dataset of 8 cross 8 image data points that we can see here from this scikit-learn website, or you can look for yourself and have a look on this. This is basically a handwritten digits. Here we will not work on the whole dataset. We will only focus on digit 1 and digit 8, and where digit 1 stands for, here digit 1 will correspond to -1 and digit 8 will correspond to 1. Now after loading the data, we will split the data in proportion of 0.5. After that, we will call our Adaboost classifier with number of classifier, or you can see the number of decision stumps equal to 5, and we'll fit the data on the training set and we'll predict on the test set. After that, we'll measure the accuracy of the decision stumps, or the collection of decision stumps, or you can say Adaboost. And after that, after the definition of main function, we will call the main function here, and we can see the accuracy is 0.89. So this is how Adaboost is implemented, and the link to this particular notebook will be in the description of this video. I hope you like this video. Please do like and comment if there is any problem or any flaws in this video.